Hi, my name is Kane. I'm a lead site reliability engineer at New Relic. And so there's a lot of talk nowadays about the advantages of modernizing infrastructure, technology, and our processes. And although these efforts often sound enticing, the thought of actually executing on such a massive organizational change can be incredibly overwhelming for people. Today, I'm going to share how in 2018, New Relic took our older, organically developed US region and all of the surrounding processes and transformed those into a modern, reliable, and repeatable system for generating regions on a global scale. Because we're all on this journey together, I want to share our story. And by doing so, I hope that we can help encourage you to implement bold and forward-thinking changes inside your organizations. So if you've ever wondered, why should we modernize our infrastructure? Or you felt that you were too big to implement broad change, or you simply needed some good ideas to convince your organization why you should modernize, then this talk is intended for you. But before we go much further, I'd like to take a moment to define a few core terms that I'll be using throughout the talk. So in the context of this talk, a data center is a single building that houses physical computer systems. And a region is a redundant group of data centers that all together provide the computing power for a software deployment target like US staging or US production. So in early 2017, New Relic only had a single region located in the Midwest United States. This region was made up of multiple data centers, but potentially could still be negatively impacted by broad regional events. In 2017, most of our computing was on hundreds of bare metal servers inside these data centers. But like most of the industry, we were utilizing cloud infrastructure more and more, and we needed to find better ways to integrate it into our broader infrastructure. Despite the fact that our single region in the US had served us well for over a decade, in early 2017, it became apparent that New Relic had numerous business needs that were going to require the development of new regions. And although we certainly could have settled on just trying to stand up region number 2, we quickly realized that we might be able to design a solution that would allow us to spin up regions almost as easily as we might spin up a new service cluster. So, however, we were also well aware that there were lots of cultural and technical issues that we would need to surmount if we're going to be able to achieve this goal. A few years ago, New Relic went through a significant reorganization of the way that our engineering teams worked. This was done to help break down organizational blockers and to also provide teams with much deeper autonomy and code ownership. In essence, each small engineering team had become its own functional unit. This did wonders for velocity and day-to-day operations of these teams, but by design, it actually made cross-organizational projects a little trickier. This multi-region effort we were about to embark on would be one of the first times that we would test how well we could take a strategic project that was prioritized at the organizational level and coordinate across a broad range of semi-independent teams while still giving them a lot of room to self-prioritize specific tasks at the more tactical level. At the start of this project, New Relic was over 10 years old, and we had the technical debt to match our age. Our US region had been organically grown over the years, and because of this, it had a wide range of technologies and processes that were required to manage it. And many of these processes overlapped, and it was often unclear to teams what the current best practices were. This project was going to require us to be very honest with ourselves about where we stood, what we could change, and what we would simply have to work with. Like most organizational change, this project was driven at its core by several specific business needs, in addition to some aspirational goals. When we started to consider the business drivers, the use case that actually intrigued us the most was around disaster recovery. Now, this wasn't because we thought that there was a high likelihood that we would experience a region-encompassing disaster, but instead because if we approached the project from this perspective, it would help ensure that we designed a system so that everything could be built up from scratch. This perspective would help us ensure that we avoided assumptions about what was already available in the environment. In theory, this would then allow us to repeatedly spin up a new region and then completely tear it down during testing cycles, which in turn would help us ensure that we were always testing that the new processes we developed could actually take us from nothing to a fully functional region. As a global company, we also need to ensure that we have the flexibility to respond to regional laws and ensure that we handle our customers' data within agreed upon parameters. This is an important step to ensure that New Relic is considered a trusted steward for all of this data. And finally, because our international customer base had been growing rapidly, taking the time to bring the UI and data closer to our customers should improve performance and their overall experience. Probably like many of you, we were in a situation where we were starting to outgrow the systems that had gotten us to where we were, yet many of the potential paths forward were both complicated and risky. When the business first proposed this project to New Relic Engineering, we immediately realized that the scope of this effort could be huge. So we took a step back and we looked at our existing infrastructure and considered at a high level what it was we wanted to ensure that we fixed as we designed and implemented this project. The first core concept that we landed on was repeatability. It was important to engineering that the solution was not focused on simply building out our second region, but that we were building a system that would allow us to build out any number of future regions with the exact same process. The second major feature was consistency, which is directly related to repeatability. With consistency, we wanted to ensure that the regions would all look the same and expose the same interfaces for all the other teams to rely on. This meant that a region in one cloud provider could not deviate significantly from a region deployed onto bare metal inside a data center. The interfaces and functionality that we exposed needed to be consistent. And finally, automation was critical. We had to automate a lot of things, but unfortunately not everything. So this was especially true as you dove deeper and deeper into the infrastructure and started to touch things that had been running and supporting the environment for many years. With this project, it was important that we determined how to automate everything so that there would be very limited human involvement needed when creating brand new environments from scratch. But to accomplish this, we needed to invest a lot of human effort up front into building the best solution for the project that was in front of us. Similar problems to these are probably shared by many of us in this room. So at New Relic, we asked ourselves, where should we start with this project? One of the earliest things we decided to do was create a very small engineering team made up of only 5 engineers who, when taken all together, had a broad range of technical skills and deep knowledge of the New Relic environment. Like the tugboat above, this team would be purpose-built for the project at hand. This would allow them to be agile and stay focused on the specific goals of the project without being distracted by a lot of the other priorities within the company. In addition to delivering technical solutions, this team was expected to be the primary source of communication and coordination that would be required to ensure that the broader organization was well-informed and set up for success. To remain as agile as possible while managing the large scope of this effort, we decided to design the whole project around a small iterative process where we identified the next major step, designed a solution, and then tested and implemented it. This helped to ensure that we discovered unknowns and potential blockers very early in the process when we could still adjust to them. After setting up the team and defining our basic working process, we then proceeded to do a survey of all the technology and tools that we were already using. As you may notice, this included a great deal of overlapping solutions. Most of these tools were not consistently used across the company, and even the way in which they were used varied depending on when teams had first adopted them. It was obvious that we needed to limit this down to a well-defined set of choices if we were going to have any hope of really pulling this project off. So after some initial discussions, we had a pretty good idea of what we wanted to scope the technology choices down to. But we still needed to prove that our understanding of the requirements was solid and that these technology choices would work as expected for every use case that we had. By consolidating our tooling so that we had fewer tools responsible for each aspect of the process, we helped ensure that we could focus on deeply understanding each tool and then integrating them into the project where they fit the most naturally and provided the most direct benefit. In the early stages of the project, we created a very lightweight centralized web portal that we could use for communication and coordination efforts across the broader organization. Then we spent some time defining a core set of results that we wanted to achieve, while also identifying the technologies that would enable each of these to work. We knew right away that we wanted to ensure that we were building interfaces at each layer of the process. This was critical if we're going to be able to make the process pluggable and ensure that we could migrate it to new data centers and providers and back-end technologies in the future. Docker helped us a lot by ensuring that we had a standard software packaging format, the Docker image, and a single deployment interface, the Docker API, that our internal Linux container platform could leverage. Docker also gave us solid visibility into things like container statistics and events that we could then ship off to other locations, including our own New Relic product. Relying extensively on Linux containers meant that we could move away from supporting multiple Linux software packaging standards like deb and RPM and APK, and instead focus solely on building portable container images. The natural isolation of containers also made it much easier to deploy various services onto the same systems without being concerned about conflicting libraries, language interpreter versions, etc. To help facilitate automation, we knew that everything would need to be defined in code, right? So to build infrastructure from scratch, we had to ensure that there were not a bunch of manual steps scattered throughout the process. We wanted to be confident that a new region could be bootstrapped with a minimal number of steps. So to accomplish this, we leveraged Terraform and CoreOS. Terraform is used to manage API-based operations on most parts of the infrastructure. Using Terraform, we can easily and simultaneously create, modify, and delete all of the infrastructure resources that we need to exist across multiple providers. These resources can include almost anything that can be managed via an API, like DNS entries, compute nodes, and object storage buckets. Within our Terraform code repository, each suite of New Relic services has its own configuration, which programmatically creates all of the required resources for that service. By ensuring that we spin up the Terraform configurations for each of these components, we can be confident that we have all of the core infrastructure that we need for a new region. Each of these service folders contains a few Terraform files which define what infrastructure components that service needs to have set up, as well as defining any data from the resulting API calls that we've determined are important and would be useful for other systems to potentially consume. Each individual stanza inside the Terraform file defines a resource, like a DNS entry, and all of the data that we expect to be set and that is needed by the related API to properly manage that resource. Our Terraform workflow is then managed by a Jenkins job, which can be used to ensure that the code changes interact as expected with the real infrastructure. Whenever a pull request against this repository is made, Jenkins will perform a Terraform dry run, which tells us what Terraform would attempt to do if we decided to actually apply those changes. Jenkins then injects the results into the PR comments so that it's very clear what running those submitted code changes will do. When the pull request is then merged into master, a new plan is run, and if that plan is then approved, the changes will be applied to the live environments. CoreOS, on the other hand, provides a tool called Ignition, which can be used to define exactly how the operating system should be set up on its first boot. Ignition basically provides a well-defined, one-time configuration management run during a host's initial boot. Using a simple JSON file, engineers can define exactly how things like disks, file systems, individual files, and users should be configured on the system. To support Ignition, we decided that each compute node would have a single role assigned based on what its role was. Every node with the same role would be set up the same way, and that role would be defined via a simple tag on the compute node. Despite the fact that Ignition actually expects a JSON file, we store the configuration for each role in multiple YAML files. And this is simply because YAML is more human readable than JSON. So each YAML file contains one or more of the sections of data that Ignition natively supports for configuration. As mentioned earlier, this includes things like disks, files, and users. Each section is then used to define one or more items that should be configured or created on that host system. In this example, we're creating 2 users, setting their UID, defining their group membership, and adding SSH public keys to their authorized key file. Then during provisioning, these individual files are all deep merged together into one large YAML configuration. And then this YAML file is finally converted into the JSON that Ignition actually requires. The YAML configuration files we use for node roles are actually templates that are processed by a Go service which we built in-house. This allows us to easily inject things like secrets and environmental settings into the configuration from Vault and other sources without needing to store sensitive or variable data directly inside our repositories. Each yellow line above will cause the system to look up a secret from Vault and inject those results into the file that is generated from this template. The next thing that we wanted was to actively move towards an immutable infrastructure, a model that encourages re-provisioning hosts regularly over performing ongoing configuration management on them. Since every hardware-owning team at New Relic is responsible for its own operational tasks, it was important that the system we built was trustworthy and that teams knew that they could rely on it. Since in most cases trust comes from experience, we wanted to be sure that we built a system that could safely and quickly re-provision hosts, so that teams could do this frequently and reliably. As we just discussed, for this we leveraged CoreOS's Ignition and Vault, so that we could tag a node with a role, and then Ignition would set up the new system according to the defined configuration for that role, while also leveraging Vault for any secrets or service endpoints that it might need to write into those configuration files. Containerization was incredibly important for the project. CoreOS has no package manager and almost exclusively leverages containers for installing and running software. Granted, we could have picked a more flexible Linux distribution, but this choice actually helped enforce the container-first habits that we are trying to encourage in our teams. And in most cases, most of our teams had already made the conversion to containers. In addition to providing us the Docker API and Docker image interfaces, it also meant that all of the build steps for the software that we developed could be well encapsulated within the Docker file and relied on to be immutable outside of scheduled builds and deployments. So we use containers for everything at New Relic. This means that even low-level software that some of the core infrastructure teams rely on, things that cannot easily run inside our own internal container platform, are still containerized. In most cases, we leverage systemd and Docker so that the general functionality and experience is as similar as reasonably possible for all of our teams that are deploying software. However, the majority of software inside the company is deployed into our highly scalable internal platform, which then schedules and orchestrates all of the services that New Relic needs to run so that we can deliver our product to the customer. Once the core software was deployable on a host, either natively via systemd or via our broader container platform, then we also needed to ensure that everything is discoverable. So we started just by standardizing the naming for most entity types that might be represented by DNS. This helped by deprecating a lot of conflicting naming styles that have evolved over the years for our endpoints. Since it's possible to use Vault as a basic key value store, we decided to actually leverage it to bootstrap the discovery of service dependency endpoints and authentication information. This means that services do not need to inherently know anything about region-specific URLs or tokens that they need to connect to. Instead, they will get fed this information during deployment. To accomplish this, we developed an internal service called biosecurity, which is leveraged by Grand Central, our unified deployment tool. Using these two tools, it's now possible for all of our services simply to define what URLs and authentication information they need at startup, and the correct information for that environment will get injected into the service during deployment. In the above example, we see a team defining two environment variables that will be passed into their containers. When that service is deployed, these environment variables will be automatically converted into the correct values for their region via data that's stored in Vault. Even though the base URL is typically standard within a region, authentication data is typically unique to every single service that is deployed. The system supports returning both authenticated and unauthenticated URLs based on this data that we keep in Vault. During this whole process, we also actively looked for places we could replace older tooling with our own New Relic solutions to greatly improve and consolidate our visibility into the state of our own environments. Tools like containerized infrastructure agents, synthetic monitors, insight dashboards, and alerting were invaluable in consolidating how we monitored and where we had to look for the data we were required to make informed decisions. So, although immutability is an important goal, we also still wanted to make sure that we recognize that it was going to take some time for teams to adjust to this new paradigm, and that we still needed to be properly prepared for anything the real world might throw at us. For example, if there was a new security exploit, Terraform would allow us to easily reprovision hosts with a new CoreOS update. However, sometimes that simply may not be practical or reasonable depending on what the issue is and how many hosts it impacts. Because of this, we also developed an Ansible container that was ignition aware and could roll out file-based changes to a fleet of hosts easily. This meant that if something simple like an SSH configuration file had a security issue, we could fix it in ignition for new hosts and still reliably be able to push out that same change out to hundreds of live servers without being forced to reprovision them all for such a small, well-defined change. The ignition-aware container that we developed for this purpose is also designed to run via Jenkins workflow. Jenkins can run Ansible in check mode and highlight many of the alterations that would be made if this job was run for real. And once those changes have been confirmed, then the final job can be kicked off and the fixes can be applied to as many systems in the fleet as required. By deciding to stand up a small and agile team that could focus exclusively on the goals of this project, we were able to quickly identify where we should spend most of the time to improve the day-to-day situation for engineers while also meeting the overall business goals. And even more importantly, it enabled us to deliver a more reliable and low latency product to our customers. By handling the project the way we did, in just under a year, we were able to take our single region in the United States and add another fully functional production region in Europe. But it didn't end there. While developing the European region, we completely built and tore down that region 4 times. And then a few months later, we used the exact same tool chain that we had used for the EU to run our official disaster recovery event in the Southwest United States. In previous years, our DR events had been incredibly laborious for engineering. That year, we lowered the engineering hours required by a magnitude of 10, and we actually cut the budget by 25%. We also expect over time that we should be able to trim a lot as we improve this process and iron out more of the wrinkles. And sure enough, just last month, we actually finished up our 2019 DR exercise, and the improvements from last year were already tangible. We don't have hard numbers yet, but on the surface it appears that engineering costs and time for this DR event might have still been reduced by as much as 2/3. And we won't stop there. We have plenty of ambitious plans for the future on our infrastructure. Going forward, we want to look into breaking up each region into fully functional autonomous cells that provide a defined set of functionality within well-understood fault tolerance boundaries. This will allow us to easily scale core parts of the system that provide important functionality, like data ingest, but are comprised of many individual services and data stores. We will continue to build new tooling to improve our ability to manage all of the regions in a simple, coordinated fashion, while we will continue to improve existing tooling by simplifying the interfaces so that they only expose the necessary details to our users. I sincerely hope that this talk has given you some insight into how New Relic approached solving one of its own modernization efforts and gives you some encouragement that you can do the same thing within your organizations. To paraphrase Margaret Mead, never doubt that a small team of thoughtful, committed people can change the world. Indeed, it is the only thing that ever has. Like the tugboats in the video above, as long as the organization is open to change, then small teams, properly aligned and leveraged, can move the whole organization in new, forward-looking directions. Thank you very much for your time today. If you have any follow-up questions for me, feel free to ping me online or in the conference hallways. And finally, if you can take some time too, please, to fill out the survey either via the website or the events app for this presentation, we would greatly appreciate you taking the time to do that. Thank you very much. Have a good day.